Hello and welcome to this video presentation. Today I'm gonna show you how we can use this new template. It's actually a combination of ACI PRC-211.1 of 2022, the absolute volume method, combined with the ACI 211.6T, which is the aggregate suspension mixture proportioning method. So as you can see, I have here normal mix 5000 psi, which is already complying to its property requirement by the right water cement ratio, the right amount of cement content, also the combined grading. So now I would like to show you how we can simply use this template to turn this to a self-consolidating concrete. So start with let's say I need here 650 mm flow plus or minus 100 mm. So it's going to be 550 to 750 millimeter diameter, the spread for the flow for the self-consolidating concrete. And of course, to easily get that, I suggest you use the 9.5 or 3/8 nominal maximum size of aggregate. Let's remove this for a while. So here, automatically, if you are designing non-air drained concrete, which is the normal mixture, especially here in the Middle East, so automatically you'll get a required 3% air content, which is the naturally entrapped air as suggested by the ACI. So here we have to just revise the proportion. First 340, here you can say 48% 10 mm or 38 and 52% for the sand. So total 100% in combination. And meantime, let us just use the combined grading just to present the curve. So this is how it will look like, because we don't have 3/4 inch. So most of this combined grading chart that you will see here, they have 19 millimeter or 3/4 inch or higher nominal maximum size of aggregate. So for this reason, I just have to use this combined aggregate grading. You can also select fine aggregates just to double check. So our fine aggregates is okay. Our coarse aggregate is also okay within the limit. But for the combined, let us just use this kind of presentation. So moving on, you notice that most of these cells highlighted in blue color, these are the cells which you need to enter the value, or you are required to update the value. So here I automatically did this calculation, but you can do, I encourage you to do the actual dry rad and bulk density. So just to show you how it was done, so this 1951 was automatically calculated here. You can see here 48% 10 mm or 3/8 inch, and the natural sand 52%. And this is the theoretical calculation and the aggregate voids. But I strongly encourage you to do the actual according to ASTM C29. And you can use the 14-liter sample container to do this test. So once you verify the value, let's go back here. So you will enter the value for the combined, which is the 10 mm and the sand, combined dry rad and bulk density, and the combined aggregate voids, which is 24%. Next would be the combined angularity factor, which is 2.4. This is automatically calculated upon entering the value of your shape angularity factor. So from where we will get this data or sources for this value, this is the table coming from the ACI 211.6T. So if you choose number 1, which is the natural or normally the rounded aggregates, that's why our natural sand here, I entered here shape angularity factor of 1. And number 4 for my 3/8 inch nominal maximum size of aggregate here. So if you combine these two according to the calculation or based on the calculation provided by the textbook, you will have a combined shape angularity factor of 2.44. So now, since we need self-consolidating concrete, the workability that I will choose is SCC. Here, the minimum spacing or spacing paste and air volume would be 12.7. So from where it came from this table. Again, based on the combined angularity factor and based on the workability that you need, we need to have a minimum spacing, paste, and air volume of 12.7, which is coming from this figure. To do that, you need the proper calculation according to the textbook. So here, to make it easy, I have here the value 12.7%. And you can increase also by 2% as per the textbook or the guidebook, just to have more robustness or to improve your uh, workability, just to have more lubrication. So you can increase up to 2%. So the total volume of paste and air as calculated is 35.7. So we are lower than that value. That's why the red notification is here. So to do that, we have to increase the cement content by just simply pushing this button till we reach that value, or to be equivalent to that value or higher will be better. So here exactly 35.7 using 460 kg of total cementitious material. In this presentation, I just use a normal OPC or type 1. For the water cement ratio, referring to this table, which is coming from the ACI 211.1 non-air entrained, you can visually verify it. So 6,337 over here, and the water cement ratio would be 0.39. So if you visualize an imaginary line here, it will be somewhere here 0.39, which means most likely it is a reliable source for the water cement ratio, which will provide you the 6,337 psi at 28 days. So your required strength is 6,200, and your calculated based on the design, the calculated strength will be 6,337 psi at 28 days. So going down here, just to explain to you, so the mixing water would be 0.39 multiplied by 460, which is 179. So if you feel this water is too high, you can decrease or reduce the water cement ratio. But again, it will be your volume of paste and air will be decreased. So in this case, you can increase again the cement content. So 475. Because normally I'm getting a good workability or flowability in this 0.37 water cement ratio. But using your own material, you can try the 0.39. So moving on, we have mixing water of 175. And here the volume of paste plus air is 0.36. So the summation of all this water, cementitious material, and air, which is 3%, is around 0.36 cubic meter. And of course, the remaining is 0.64. Simple as that. 0.64 is the volume of coarse aggregate. The finest modulus I just included just to show for the sake of our ACI textbooks. But actually, you don't need it for the calculation, just for the sake of presenting it well. For the aggregate material finer than 75 micron, we have here 1.1%. According to textbook, it will be negligible if less than 5%. If it was 5% and above, then we have to consider it as part of the paste according to the textbook. So in this equation, the ratio of base plus air over aggregate voids is 1.49. And here, if you look down the note, you can see here as suggested from this note, according to some textbooks and researches, it's 1.25 to 1.5. The recommended value of base plus air over aggregate voids, 1.25 to 1.5 for self-consolidating concrete or SCC. So in our case, as calculated, it was 1.49. So can say we are most likely we will have the best workability for this self-consolidating concrete. So going down here, this is our the final batch weights. We have 475 type 1 cement, 171 water. Our mid range, I would suggest start with 8.5. I'm talking about my experience. So around 1.67%. And let's try to add a retarder since you wanted to have 650 minimum flow when it reaches site. So to have that retention, I normally use a retarder so that I can deliver it at 650 minimum flow, which is best for self-consolidating concrete once it reaches site, perfect for consolidation. So as you can see, it was very simple, straightforward. This is why I like this template for this year 2026. So that's all for today, and thank you for your time watching this video. I hope you like it. I hope you learned something, and goodbye.